When you're designing your custom part, it's important not to forget to optimize it for scaling. In this video, we are going to cover what you need to keep in mind to optimize your part. An automated assembly line is a manufacturing setup comprising of machines and stations that work together to process and assemble manufactured parts into finished products. These assembly lines are designed to streamline production processes, enabling companies to scale up their quantities while reducing the individual unit price. When optimizing your part, it's important to determine what level of automation you need. Change your design to fit the level of your automation, acquire the correct machinery and components, run pilot tests, and use the data you collect to optimize further. This step involves assessing your production goals to determine what level of automation is required. Factors to consider include volume of production, complexity of design, and the assembly process. When looking at the volume of your part, low volume might not justify the cost of automation, while higher volumes might justify that cost. For design complexity, it's important to note that simpler designs are easier to automate than complex ones. Based on these factors, you can decide whether to fully automate or just do manual processes for your project. Once you have decided on the level of automation, it's important to adapt your product design to facilitate the manufacturing process. This involves considering factors as presentation format, liner removal or facilitation, and design complexity or your tolerances. Presentation format refers to how your part is packaged, most commonly made as sheeted parts or parts on a roll, with the latter being more suitable for automation due to easier handling. It's important to consider liner removal facilitation because designing parts with features that facilitate liner removal can simplify the automation process, especially for adhesive components. Lastly, looking at your design complexity can help with simplifying the design and tolerances, which will improve automation feasibility and reduce manufacturing costs. After finalizing your design modifications, you need to acquire the correct machineries and components for your automated assembly line. Considerations include existing equipments that are already available, are you capable of making these parts in-house or you need to outsource, and what are the logistical factors that can affect you, such as floor space and operator training. Before full-scale implementation, it's important to conduct pilot tests to validate the effectiveness of your automated assembly process. This involves running the process on a smaller scale to identify and address possible issues early on. Analyzing the data collected during pilot test is the most important way to fine-tune and optimize your automated assembly process. This approach allows for continuous improvement and ensures a reliable and efficient production system. Optimizing your product for automated assembly requires careful planning. If you have any more questions, feel free to visit our learning center or reach out to us directly. Thanks for watching.